Hello learners, welcome to Hope Channel Kenya. Today we are in this particular program. The program is the Knowledge Quest, and in this program today we are learning mathematics. Topic for today is statistics. Stay tuned. So let's begin. So we say that today we are learning mathematics. So we are doing mathematics. Very good. So the topic is statistics. So we talk about statistics. All right. So we may be wondering why we are learning statistics, or what is statistics. But before we look at the definition of statistics, let us get the basic outline. What are you expected to learn in this particular topic of statistics? So we have the first thing we are going to discuss is called definition. Definition of statistics. We will know what statistics is, what statistics entails, and even why we study statistics in mathematics. The second thing we will also be discussing here is called data presentation. We will be discussing what is called data presentation. Good. So in this section of data presentation, we'll be looking at various ways in which we can present our data. Then the third thing we will be discussing here is called data analysis. So we will be looking at what is called data analysis. Yes, so we'll be looking at various methods that we can use in order to analyze a statistical data. Then maybe as time goes, we will also be discussing something called interpretation. So we will be talking about interpretation of data. We're talking about interpretation of data. So these are the key things that we are going to learn in this topic of statistics. And I expect that by the end of this particular lesson, learners will be able to define correctly what is statistics. They will be using different methods on how to present data, as well as carrying out what is called data analysis. So let's dwell into what is statistics. So I will come here. Let me just use this other section and write statistics there. You know, statistics, from the first thing we will be discussing here is the definition. So I want us to maybe think statistics. I know some of us may be having the idea now as we speak. Others may be fumbling around thinking, what is this? But I know some of you, you are good students. Others have done statistics. Others have done statistics before. Others are meeting it for the first time. But all in all, at the end of this class, I expect that we will be able to understand the key concepts of statistics. Good. So what is statistics? Statistics is a branch. Statistics is just a branch. It is just a branch of applied mathematics. A branch of applied mathematics. A branch of applied mathematics that deals with a branch of applied statistics or mathematics that deals with, I want to list all these components. I want to list all these components of statistics. First, it deals with what we call data collection. It deals with data collection. 2, it deals with data classification. Data classification. It deals with data classification. Another thing that statistics deals with is called data presentation. Data presentation. Data presentation. Statistics also deals with data analysis. Deals with data analysis. Data analysis and interpretation. Data analysis and interpretation. Data analysis and interpretation. So we say statistics is a branch of applied mathematics, a branch of applied mathematics that deals with 1, data collection, 2, data classification, 3, data presentation, and lastly 4, data analysis. So meaning, once we are done with the topic of statistics, once we are done with the topic of statistics, what will you have known? You shall have known the basic concepts of what? Data collection, the basic concept of data classification, data presentation, as well as data what? Analysis. Good. Students, now let's proceed. Data collection as the first concept. Data collection as the first concept. Data collection as the first concept. Now, students, maybe the students who are doing geography, or those students who are doing some social sciences, have ever come across what is called data collection. In your class, in your classroom, we do some data collection. You'll get, maybe somebody will come. Like sometimes in our schools, we always meet strangers. We meet visitors from different institutions, coming to know how many boys are in this class, how many girls are in this class, and as well as even what did you eat yesterday. You know, sometimes the first thing that maybe students always ask themselves, oh, the menu. You know, I remember in our school, there was a day that our favorite day. Our favorite day, we were taking meat. Actually, there was a slice of meat. Yes, though some people were complaining, I don't know if it is if a slice is less. Then we were also having a very maybe a cup of soup. So people were like, which day is that? A new student is admitted. Then we are going to ask ourselves, or the students will be asking, today we are eating what? That one is an element of what? Data collection. So what are you supposed to know about data collection? This is a theoretical part that we are just going to brush over for you to understand, because it is a necessary thing that you need to know before we can even proceed to those calculations part. So data collection, we have different methods in which we can use to gather data. One of these methods, which is the primary method, is called observation. Observation. I know somebody is now looking, somebody is very keen, glued to the screen. What are you doing, or what are you seeing? Whatever the sense you are using in that case is the sense of sight. What you can see, let me just, these are the things we do with our common senses actually. You know, we talk about observation. Observation is what we do with our common senses. In primary, we were told that we have 5 common senses. The first one is the one for sight. So what you can see, that is observation. Another common sense is maybe taste. What you can, how does it look like? Like that soup, was it sweet, was it sour, and the rest. Another thing, maybe another sense, another thing you can do, yes, maybe let me talk about maybe something like a sense of touch or the feel. How did you feel it? Yeah. How did you feel it? Was it too cold? Was it too hot? You get that one, eh? So all this, yeah. You know, sometimes when you talk about the five common senses, some students always ask, hey, some senses are not common. There are very many actually, because even if you start listening to music, then you dance. I don't know which sense we are using that, because the five common senses, what you can see, what you can hear, what you can taste, what you can maybe touch. But now if somebody starts dancing, are they using their common senses? That is a question of tomorrow you will answer. Another method of collecting data is interviews. Yeah, another method of collecting data is interviews. So an interview involves maybe oral questioning. Yeah, you do an oral questioning. Maybe you have a group or you have an individual, and this group you are seeking information from them. That is an interview. We also have what is called questionnaires. We also have questionnaires. We have questionnaires. A questionnaire in this case is a written. Mostly questionnaires are written questions. You're passed, maybe sometimes you're required to answer them anonymously. That is a questionnaire. So we can have other methods, but the most common ones are observation, we have interview, as well as we have questionnaires. I know some of you back there are asking themselves, what are the advantages? What are the disadvantages of these particular methods? You will be you just write you'll be just noting down some of the advantages. What do you think? Like observation, what can interfere with it? That is a disadvantage. You can also look at the advantage part of it, but that one is not part of the class today. Actually, we are only interested on collecting data using these three methods. So these three methods are always basically used to collect a type of data that we call primary. So we use it, we use this one to collect a type of data called primary data. Then nowadays, after primary data, nowadays we have, we are in a digital world. Actually, I heard the other time that there is a generation that has come. This generation is called Gen Z. So Gen Z, their strength we had is online. So you can go online and ask Google the best food to eat when I want to become fat. Which type of food should I eat when I want to become fat? So you'll be getting some list of foods. Those are called secondary data. So you can use research, you can use surveys, many methods that you can use, like what is written in the newspapers can help you get other type of data, which is called primary data. Good. So the first part of statistics, data collection, that is the thing that you're supposed to have. Yeah, so much can be talked about it, but for now and for the purpose of this our class, we wanted to get a proper understanding on the basics of data collection. Very nice. So let's proceed. Let's proceed. Let's proceed. So let's proceed to the second part. The second part is called data classification. Data classification. You know, classifying data simply means to group. Actually, the word classification in English simply means to group. Grouping maybe this data according to maybe similarities as well as differences. Similarities as well as differences. So the data, things that are maybe in the same category are put together. The ones that are in another category are also put together. The reason of doing that is that statistics requires what is called order. The data presented must have an order. So in such a situation, we have to classify data. It is one of the preliminary methods, the preliminary steps that we take after collecting data. So after we have collected data, we need to sort them out so that we know this is necessary, this is not necessary. So once we have known, or once we have remained with what is necessary, now we go to the third section of the definition, which is called data presentation. So this one is now called data presentation. So data presentation is a way of summarizing a data. Yeah, a way of summarizing a data. Because assuming that I go to, or maybe I go to your class, then this class is having 50 students. Yeah, a class is having 50 students, and I want to seek, a class is having 50 students, and I want to ask maybe how many students, or everybody should maybe tell me their age. So I want to know the age of students in this class. So it will be a long list. It will be a long list. John will say, I'm 13. Mary will say, I am 17. Mike will say, I am maybe 16. Metley will say, I am 10. Lekisha will say, I am 13. So look at this list. It will be a very long list. So for you to summarize this long list, because assuming that now we have maybe 500 students, so it will be a very, very long list. So in order to solve this problem, we need to present this data. So presenting data is a way of summarizing a long data into a very manageable size of data, where somebody can seek or can get some information out of this particular data. So how do we, that's the big question now, how do we present data? How do we present data? Good. One of the methods of presenting data, is called use of tables. So data can be presented using tables. Yeah, you can draw a table, then you make a summary of this particular data. So the commonly used table in statistics, is known as frequency distribution table. So we are going to discuss how do we construct a frequency distribution table. Another way of presenting data is use of charts. So we can use charts to represent data. The common charts that we use is pie chart. This one, I know you studied it, you have come across it since your primary level. You know how a pie chart looks like, but we will also discuss how do we present a data on a pie chart. We also have what is called a bar chart. So a bar chart is also a method that we will be using to present data. So among other charts, we will be discussing all these ones. So remember, we can also use another chart which is known as, by the way, bar chart is also known as bar graph. Because somebody will asking, what is the difference? Bar chart and a bar graph. Somebody will be asking, what is the difference between a bar chart and a bar graph? That's okay. Then we also have a use of pictograms. So we can use pictograms. We can use pictograms. So pictograms is from the word picture. I remember when we were growing up, we used to draw a man like a boy. A boy was being drawn like this one. I don't know how the boy was being drawn. They were saying this one represent a boy. Then when I want to draw a girl, I will do something almost similar. Then here in between, I put something like this one to represent maybe a skirt. So I don't know even nowadays how do you usually do it. Because nowadays, boys and girls are all putting on trousers. Because this one was used to represent a skirt. So I'm wondering, nowadays when you are taught how to draw a boy and a girl, so how will you differentiate them nowadays, now that all of them are putting on a trouser? But yes, during our times we used to draw them that way because it is. So this is an example of a pictogram. Then we can also use other graphs. We can also use other graphs. We can also use other graphs. These other graphs include things like, these other graphs include things like, these other graphs include things like 1, histogram, include things like histogram. 2, include things like frequency polygon, include things like frequency polygon, include things like frequency polygon. And lastly, we have what is called cumulative. We have what is called cumulative. We have what is called cumulative frequency curve. Cumulative frequency curve. The one that sometimes is also known as an ogive curve. An ogive curve. So basically, those are the major methods on which we are going to present data. So in our series of discussion in this topic of statistics, we will be discussing several methods that we can use to present data. We said we can use tables, we can use charts, we can use pictograms, as well as we can use graphs. So that is good. Then data analysis. Data analysis is the last part. Data analysis is the last part. Data analysis means from the presented data, we are going to do some calculations that will make us, will enable us make an informed decision. So this area of data analysis, it is an area that we will be discussing in details in our subsequent sections of this particular topic. But now, to summarize the introduction part of it, I want us maybe to ask ourselves, why statistics? Why statistics? Why statistics? That is the biggest question. Why statistics? Or why is statistics being taught in this section? So we are going to take maybe some of the real life situations under which statistics is being applied. So as we gear towards this one, let's now take a short break. Let's take a short break as we now come to the second section of this particular class. Welcome back to the show, Knowledge Quest. So I'm your teacher, Mr. Aguk. So we're now dwelling into the best or the first part, which is now the most critical section. And I want you to be seated well, because whatever we're going to discuss in this second section is what you need. Actually, this is what majority of us have been waiting for. So from where we stopped, we were asking ourselves, why statistics? Like, what is the importance of studying statistics? So statistics is one of the major important areas. And actually, we are applying statistics in our daily lives. Like in school, the teachers will always use statistics to analyze. The teachers will use statistics to analyze the performance of students in the class. Yeah. Who is number one? Who is number two? Yeah, that one is statistics. Statistics is used in economy. Like, we want to know, why is the price of bread continuously increasing? We will need data to answer that. Statistics is used in health. Like how many people, or what is the HIV prevalence rate in a certain area? That is statistics. Statistics is used in engineering, because they want to know which component is fitting here best. So we have many. So statistics is applied everywhere. That's why you will find statistics being studied in all over all the courses that you will be doing even after your high school. So let's just move to the first part of this section. Without wasting much time, I want us to start with what is called data presentation. So just start with the data presentation. So we have said the data presentation, we can use tables and we can use what is called charts. So let's begin with the tables. And when we are presenting data, I said the most common table that we use in statistics is called a frequency distribution table. A frequency distribution table. So we are using frequency distribution table. As the name suggests, a frequency distribution table, meaning that it is a table. You know, a table is always defined by rows and columns. Yeah, a table is always defined by rows and columns. And it is a table showing how frequencies in this case is the number of occurrence, how many times does an observation occurs? How many times? That is the frequency. So we are going to look into a data. For example, if we say that in a class there is age 17 years. So we'll be asking, this is the age, 17 years. Then frequency in this case is that how many students in this class are 17 years. If we found out that 10 students are 17 years old, then definitely 10 becomes the what? The frequency. So frequency distribution table is just a table that is showing how frequencies are distributed within the observation. So that one is now very, very clear. So how do we prepare a frequency table? How do we prepare a frequency table? Very easy. Just get the observation, know how many times that observation is appearing. If it is 10, ask yourself, how many times does 10 appear in that particular set of data? That one you shall have known, the frequency distribution table. Good. So let's continue. In preparing frequency distribution table, one thing that we need to be categorically clear about is which type of data are we using here. The type of data can be ungrouped. The type of data can be ungrouped, that is ungrouped data, or the data can be grouped. Yeah, so we can have a grouped data, or we can have ungrouped data. So the way we are going to present a grouped data and ungrouped data will dictate the type or how our table is going to appear. Let me give a brief difference between a grouped data as well as ungrouped data. Ungrouped data, the word means, we are talking about ungrouped. It means that it is not categorized. We don't have a class. So in a simple term, ungrouped data will have no class. But now, group data, there is classes. So the data is organized, or the data is classified into different classes. So if we are presenting a frequency distribution of ungrouped data, it is always very easy because we look at the data itself. Let's look at an example. Let me just use an example. Let me just use an example of this. So I've been talking about the age. So assuming that in a class we have maybe students aging 13 years, we have 14 years, another student was asked 15 years, another one was 13 years, another one was 16 years, another one was 14 years, the other one was 16 years, another one was 17 years, another one was 18, another one was maybe 14 again, and maybe another one was maybe 20 years. Maybe the oldest student in that class is 20. So we want to present this data in a frequency distribution table using ungrouped data. So presenting this data is very, very simple. I don't know how simple it is, but it's very, very simple. So I can just have a table. I have the age, then I have the frequency. So we'll be having the age, then we are also going to have frequency. A commonly introduced column also is a column of what we call tally. Yeah, a commonly introduced column here is a column of what we call tally. So I will have a table, my nice table. You know, mathematics, you must be always presentable. So your table must also be very nice. You should be very, very, very much presentable. So the ages, I will have to arrange, because we say that one of the things we do in statistics is to classify. So the data must be sorted. We must arrange the data in ascending order. It is always a very good practice to organize your data or to arrange your data in ascending order. So the first observation I'm having here is 13, followed by 14, followed by 15. There is also 16. There is 17. There is 18. Oh, there's 17. There is 18. And there is 20. Good. So once you write the data the way it is, just list them. You don't say many times the way they occur. If 13 occurs more than once, just write 13. Are we together? If 13 appears more than one, just write 13. So frequency in this case, how many times are for 13 appearing? So let me use a different ink to show this. So we will just be counting manually. This is 1. This is 2. Actually, the frequency in this case is going to be what? 2. Yeah, so the frequency is 2. In statistics, we use tallies. Tally is just use of vertical lines or the stroke to represent the number. The way we were counting, 1, then 2. That one is done. We go to the second number. The second number is what? 14. So 14, how many times? 14, we have 1. Let me put the tally there. 2, we put that tally there. 3, another one here. So meaning that the total number of 14 are how many? Are 3. Are we together? I hope we are following very well, and maybe you can complete the table. I know some of you are even into number 20. You know, my class is always a very active class, so students will, some of them are now, I know, some of them are now here. But let's continue. Let's just complete for the sake of the rest. 15, 1. It is only 1. That's nice. 15 occurs only once. Then 16, 1. Just put that. 2. Put that. That is perfect. So 16 is only occurring twice. Then what about 17? 17, 1. So let me just put there 1. Only 1. So that one is 17 is occurring once. 18, 1. Good. That is 1. 20, also 1. Good. So this is now what is called a frequency distribution table, students. A frequency distribution table of a data which is not grouped. A frequency distribution table of a data which is not grouped. So once you have done, or once you are you have filled the column of the age or the data itself, the frequency and the tally, there is one more thing that you should not forget. What is this that you should not forget? You should always add the column of frequency so that we can know how many observations were there. You can also, we'll be using this one to counter-check our data. We use the total here and also counter-check our data if we have actually counted all the data we have. So let's add. 2 plus 3 is 5. 5 plus 1 is 6. 6 plus 2 is 8. 8 plus 1 is 9. 10, 11. So the total here is 11. So we can also go again to our data and counter check. Let's go to our data and counter check back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good. So it means that we were accurate, and accuracy is the key when we are talking about statistics. Remember, this data will help us later on in making an informed decision about the students in this particular class. So the more the accurate we are, the more the detailed decision we'll be making using this particular data. Because sometimes somebody can ask, hii class averagely wanafunzi wako na how many years? You get that one, eh? So somebody will just come here and now do what is called data analysis. Aanze kujiuliza, hii class averagely watu ni how many years old? You will use this information now. So it is easy to get it from this end than to get it from this end. So that is now the role of data presentation. Now, how do we get it for a grouped data? So, grouped data. How do we get it? Using a grouped data. You know, first thing that you are supposed to know, that in a grouped data, the observations are arranged into classes. So the data is arranged. The data is arranged into classes. The data is arranged into classes. A class is more of a group. Yes. Instead of saying that people who are 13 years, 14 years, 15, you can give a range. You can say from 13 to 20, or from 10 to 15, or from 100 to 120. You get that one? So that is basically what we are calling a class. So a class in this case is giving us a range. So in a class, what do we need to know? We say that the data is arranged into classes. So these classes will be having what is called class width. Yeah, so we'll be having what is called the class width. The class width is also known as the class interval. A class interval. How do we get this one? Assuming that maybe we are talking about 10 to 20. So an interval, or the width, is how many observations are here between 10 and 20. Sometimes we can even decide to count it manually, that how many data or how many observations are going to fall between 10 and 20, like 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. You get that one? So definitely we will be getting the number. So that is now what we are calling a class interval. So sometimes we are going to have a data. Then somebody will be asking you, how do we find the class interval? How do we find the class interval? So let me begin with the defining how we get the class interval. So class interval in this case is equals to the upper class boundary. So there's something I'm introducing here. There's something I'm introducing here called class boundary. Upper class boundary minus the lower class boundary. The upper class boundary minus the lower class boundary. Upper class boundary minus the lower class boundary. I want to use an example. 1 to 5, assuming that these are the classes, then maybe 6 to 10. Yeah, so you have a class of 1 to 5, a class of 6 to 10. You want to know what is the class interval. What is the class interval in this scenario? Very simple. The first method tumesema ni manual method. Sometimes we can do a manual method in order to get this class interval. You can be asking yourself, because when we say 1 to 5, what we mean here is we are going to count all those numbers that are ranging from 1 to 5. This means that both 1 and 5 are included. Both 1 and 5 are included in this particular set. So we can do the manual one by saying 1, 2, 3, 4, 5. So what is the class interval here? 5. You know, somebody will be asking, and Mwalimu, you know these things, if I say 5 minus 1, the answer should be 4. The only thing that you should be having in your mind is that you should not subtract 5 minus 1 to get 4, simply because both 5 and 1 are included. When we are counting the numbers that are following there, we are going to count 1, we are going to count what? 5. Are we there? So the best way to know this is to use this particular formula. I said you can use the manual or you can use the formula. You can just count literally or use the formula. So the class interval is equals to the upper class boundary, you subtract the lower class boundary. The upper class boundary subtract the lower class boundary. So what are these boundaries? More often, when we are given a data, more often, when you are given the data, we are given the range, like 1 to 5. This one is representing a limit. So that one is representing a limit. We call it lower limit. This 5 is representing also a limit. A limit is just where to start and where to stop. So lower limit and also upper limit. Lower limit and also upper limit. Are we together? So whenever we are counting the class, whenever we are calculating the class interval, we never use the limits. We never use the limits. Instead, we use what is called the what? The boundary. So let me show you two ways on how we can come up with what is called a boundary. A boundary, like, let me use this one here, the first simplest method. This class ends at 5, and this one begins at 6. So let's just think logically. This class ends at 5, and this one begins at 6. So what is the boundary? A boundary is a number that is between what? 5 and 6. And which number is that? Because when we are counting, there is 5, there is 6. But now, a boundary is what is separating. A boundary is what is separating 5 and what? And 6. And actually, how do we usually get that one? I will simply say 5 and 6. Then I find the average. The average of 5 and 6. So what is 5 and 6? So 5 plus 6 is what? 11. 11, when I find the average, I get 5.5. So meaning that the boundary between 5 and 6 is 5.5. So this one is ending at 5.5. This one is now beginning at 5.5. So that whenever this one ends, this is where that is when the next class will do what? Will begin. So these are what we are calling boundaries. Good. Mathematically, sometimes we don't do it this way. Instead, we look at what is called an error factor. So an error factor will depend with the type of data that you are given. If the data is a whole number data like this one, the error factor is said to be 0.5. That is 0.5. So you add or subtract. So let me just mention something here so that somebody can put down. Yeah. So there is something called an error factor that we use in statistics. And the error factor will depend with the number of decimal places. For example, an error factor will depend on the number of decimal places. For example, if the data is a whole number, then the error factor is said to be 0.5. So you can add or subtract 0.5. Like in this case, if I want to get the upper boundary, I add 0.5. I will still get 5.5. If I want to get the lower boundary here, I subtract 0.5. That will give me 0.5. The same case here. If I want to get the lower boundary here, I do what? I subtract 5.5. If I want to get the upper boundary here, we do what? I will add 5.5. So let's get the case. This is 5.5 and this is 10.5. So this one will be 10.5. So using this is now what I will use to get what is called the what? The class interval. So in this case, the interval will be 10.5, which is the upper class boundary, minus the lower class boundary, which is 5.5. Definitely the answer will be 5. But if I subtract directly, if I say 6 minus, oh, if I say 10 minus 6, I will get 4. But if I subtract using the boundaries, I will get 5. So the best way to work out this is to do what? To use the boundary instead of use the boundaries instead of what we are calling the limits. So never get a class interval using the limits. And that is how we are going to discuss, or that is how we are going to present a group data in a frequency distribution table. So I urge all the learners that when you are given a data and you are required, or you are required to prepare a frequency distribution table, the first thing you are supposed to ask yourself is that, is this data ungrouped, or is this data being requested grouped? So if it is a group data, remember we have to come up with classes. So we have to come up with classes, and in more scenario, you will be required to start from the lowest, then you know the highest. So you start, if I'm given a data like this, 13, and the lowest in this case is 13, and the highest is 20, the first thing I will do is to find what we are calling the range. Yeah, the first thing I will do is to find what is called the range, like 20 minus 13 will give me 7. So that 7 is the range. So I'm going to be arguing with this range. Like this data is falling within a range of 7. So how many classes should I have? So that I will determine whether to use a class of 5 or whether to use a class of 10. Because those are the most common classes. Although we have other ordinary methods. We have other intervals that can be used in such a scenario. But the most common ones that you'll be meeting is a class of 5, a class of 5, as well as a class of 10. So we are going to look into an example. We are going to look at an example on how to illustrate this. And I believe that the part that we have done for the introduction, now you are having an idea of what statistics is, and basically we are going to dwell in this, and we are going to we are going to ensure that each and every one of us get the basic concept from the word go. Yeah, get the basic concept from the word go, so that at least when we are going to move forward, we are going to use this particular table, now putting them into practice, you know what we mean. You'll not be asking yourself why or why this is being done. I'm taking you through this process very slowly so that you can be in a position to answer some subsequent questions that are coming. All in all, I hope you have enjoyed the class, and basically I'm waiting for you in the next class, where we will be beginning with presenting a data, or we will be beginning with presenting a grouped data in a frequency distribution table, as well as now starting the analysis part of it. If you have a question, you always feel free. You'll always be leaving us a comment. You'll also be leaving us your questions in the number that is going to be provided there, so that we will be able to answer your questions as the time goes in our preceding videos. Welcome.